Hello friends, we are going to take the lesson strength of material. First, the main content of the strength of material is a basic stress. What is the stress? Stress is the internal resistance offered by the body against the load applications on this body. When the load P acts in this body, it will be deform or contract based on the type of the load. Here the load is compressive. When the compressive load acting on this body, it will be contract. Another, when the load is tensile, that means pulling, it will be deform like this. So against these two effects, against the deformation and against the contractions, there will be internal resistance offered by this body. Internal resistance against the deformation or again resistance against contract. So here the load acting on this area A. Load is acting on this area A. Then the stress will be the load divided by area. Stress will be the load divided by area. It is the load acting per area. So what is the definition of this stress? Stress is the internal resistance offered by body against the load external acting on the body. Next, unit of stress. What is the unit of stress? It is a load divided by area. Unit of load is Newton. That means force divided by area. Unit of area is meter square. It is the SI unit. So unit of stress is the Newton per meter square. Next one, type of stress. Mainly two type of stress there is. First one, normal stress. Another one is shear stress. Shear stress. What is normal stress? Normal stress is the stress in the body when the load applied on the plane which is normal to that plane. If the load acting perpendicular to this plane, such load is called normal stress. Another one is if the load acting tangentially, when the equal and opposite load acting on the tangential to this plane, such stress is called shear stress. First one perpendicular to the plane, another one is equal and opposite force tangentially to this plane. So normal stress and shear stress. Next one, type of normal stress. First one, tensile stress. Second one, compressive stress. What is tensile stress? Tensile stress is the stress against deformation. Stress against deformation. When the load acting, pulling, that means tensile load acting, the body will be deformed. So the internal resistance against this deform is called tensile stress. Also, compressive stress is the internal resistance against contraction of this body. Internal resistance against contraction of this body. When the body will be the contact. If the load are compressive, the body will be contract or reduce its width. Its length will be reduces. So this reduction in the length. So the internal resistance offered by this body against the reduction of this length are called compressive stress. Generally, tensile stress will be sigma T and compressive stress are represented by sigma C. Always tensile stress will be positive and compressive stress will be taken as negative when doing the problems. Okay. Next we are going to strain. What is the strain? Strain is the effect of the stress. When the load P acting this body, it will be reduce its length. Original length will be L. Changing length will be delta L. Then the strain will be the changing length divided by original length. So strain generally represented by E. So strain E equal to changing length divided by original length. That is mean how much factor of this length or how much factor of dimension is reduced or how much factor of dimension is increased or how much factor of volume is increased. That is called strain. Generally, changing length divided by original length. What is the unit of the strain? Unit of this length is meter. This meter. So it is the unitless quantity. This is the unitless quantity. This is the generally strain. Next, type of strain. First one, tensile strain. ET. When the tensile strain is the changing length. What is the change of the length when the stress is tensile? It is the P. Here the stress will be tensile stress. That is what is the effect of this load? The body will be deformed. Here the original length is the L. Final length will be the L plus delta L. L plus delta L. So what is the strain? Strain either is the tensile strain. So tensile strain will be the increased length divided by original length. What is the increased length? Increased length is the delta L divided by original length. Here the tensile strain. Next one. Second one, compressive strain. EC. When the body will be compressed, if the load acting compressive, then the body will be contract. So final length will be the L minus delta L. Original length is the L. So strain will be compressive strain. Is the decreased length divided by original length. Decreased length divided by original length. That is also how much factor of length decreased? Delta L factor of length decreased divided by original length. Original length is L. Here the compressive strain. Next, another strain is shear strain. It is represented by phi. Shear strain is the what is the shear? Shear strain is the change of the shape. If the load acting this type, the body will be change its shape. The result is such way. Change will be in the shape. What amount of change? Here nothing like length is reduced, no length is increased. Here the some angle is made in the body. So we have to calculate amount of angle changed. We are giving the name A, B, C, D. This point is A dash. B dash. We know that strain here phi is the changing length. What is here changing length? Here the changing length is this is. What is the original length? Original length will be so changing length here. This length is shifted into this point. So changing length is here. Original length is this. That means changing length A dash C divided by original length is A A dash, A dash. When we find tan phi, what is the tan phi? Tan phi is the tan phi is the tan phi is the opposite side by adjacent side. What is the opposite side? Opposite side is the AC, A dash C. What is adjacent side? Adjacent side is the A dash, A dash. So A dash C equal to A dash tan phi. A dash C equal to A into A dash into tan phi. When we substitute this value A dash tan phi divided by A dash. So cancelling this term, we will get phi equal to tan phi. Phi equal to tan phi. When the angle is very small, when phi very small, tan phi will be approximately equal to phi. Understand? That is tan phi is the sin phi divided by cos phi. What is the sin value of 0? That is 0. So if the angle is reduced into the 0 value, that is when the angle is very small, the sin value will be approximating to 0. That means that value. When the angle is reduced to small value, the sin value will be equal to that value. So sin phi will be equal to phi. So tan phi will be equal to phi. So we will get shear strain phi equal to phi. That is shear strain equal to phi. Shear strain equal to phi.